Hello everyone, we are back to another episode of studying for the Comptia Plus. So from the last live stream, I've skipped ahead a bit. I've done some revision without streaming just because I got really busy. So now we're on module 2.5, aiming to get to at least 3 today and then my exams in 2 weeks. So yeah, we're gonna crack on, but by the end of next week I'm hoping to complete like all the theoretical revision and then go on to doing practice and practical exams or module exams tests. So we'll get started, and the goal is for next week to complete at least a round of studying throughout all the modules. There's 5 domains, and we're going to be going through all of them. So if you're studying, come study along with me, and let's do this. I cannot hear
network,
you.
and so on. So not only are we routing between different IP subnets, we may also be converting to different topologies using our router. If you're plugged into the wired access on a network user device,
You're moving too fast, bro. Okay.
This video will show you these separate devices, and we'll talk about how each device is used to connect the entire network together. To be able to communicate from one IP subnet to another, we need a router. Routers are devices that make forwarding decisions based on the destination IP address contained within a packet.
I need something to draw. I have a Kindle Scribe to take notes, but I would have liked to be able to draw and scribble on this page here. Wondering if there's an extension to do that, actually. Is there an extension? Can I draw? Draw the IO seems interesting. Okay, that's blocked apparently. So let's try draw diagrams. Extensions, okay. Go away, go away, go away, go away, go away. What? My good sir, why am I not able to use draw diagrams? You are not here. Okay. Alright. Forget about it.
Packet,
I will draw manually on my scribe.
all in the same device. In In this video, we'll show you these separate devices, and we'll talk about how each device is used to connect the entire network together.
In case you're
To be able
wondering,
to communicate from
there's
one
a
IP
scribe.
subnet to another, we need a router. Routers are devices that make forwarding decisions based on the destination IP address. To be able to communicate from one IP subnet to another, we need a router. Routers are devices that make forwarding decisions based on the destination IP address contained within a packet. The router has a table inside that tells it where it should be sending traffic. It then evaluates that destination IP address and then sends it out the appropriate interface. Some organizations will use devices that are both routers and switches in the same device. And since routers operate at OSI layer 3, those devices are often referred to as layer 3 switches. You might also see routers used to connect different types of networks together. So it's not unusual to connect an Ethernet network to a wireless network to a serial network, a fiber network to a copper network, and so on. So not only are we routing between different IP subnets, we may also be converting to different topologies using our router. If you're plugged into the wired access on a network, then you're probably connected to a switch. A switch is a way to connect all of these end devices and be able to forward traffic based on the destination MAC address. These switches often operate very quickly, and they're able to do that because they do all of the switching in the hardware of the switch itself. Very often this hardware is an application-specific integrated circuit or it's on a network.
So a router diverts traffic between subnets, between IP subnets, and makes forwarding decisions based on the packet being transferred. And a router inside a switch is sometimes called a layer 3 switch, and you can connect different device types: LAN, WAN, copper, fiber. Okay, so it's like traffic control almost.
Per network and so on. So not only are we routing between different IP subnets, we may also be converting to different topologies using our router. If you're plugged in,
Take a screenshot.
be converting to different topologies using our router. If you're plugged into the wired access on a network, then you're probably connected to a switch. A switch is a way to connect all of these end devices and be able to forward traffic based on the destination MAC address. These switches often operate very quickly, and they're able to do that because they do all of the switching in the hardware of the switch itself. Very often this hardware is an application-specific integrated circuit or an ASIC, and this gives that switch the speed that it needs to keep up with our high-speed local area networks.
Oh, nice ad.
Since most of the wired devices on your network are connected to a switch, these switches have to have a large number of interfaces on them. They might be a 24 or 48 port switch in the case of a workgroup switch, and in the core of our network we might have switches with hundreds of interfaces on them. This is also where you might have power over Ethernet capabilities so that you would run both Ethernet data and power over those same wires. This allows you to connect phones, wireless access points, and even laptops to an Ethernet connection and have it not only use that Ethernet connection for data, but also power the device itself.
So this is what a router does.
And as we've mentioned, many switches
But at the
not
hardware
only
layer.
have the switching functionality, but might also have routing functionality in that same device. We often refer to these as layer 3 switches or multi-layer switches. Some switches are relatively simple. You plug them in, provide power, and then you connect all of the devices you need to that particular switch. There's no way to differentiate between different VLANs on the switch. The switch may not even have any management functionality or configuration settings. It is effectively a plug-and-play device. There's no way to differentiate functionality in that same device. We often refer to these as layer 3 switches or multi-layer switches. Some switches are relatively simple. You plug them in, provide power, and then you connect all of the devices you need to that particular switch. There's no way to differentiate between different VLANs on the switch. The switch may not even have any management functionality or configuration settings. It is effectively a plug-and-play device. We refer to these relatively simple switches as unmanaged switches, which means there's no management that you need to do to be able to get this switch to operate. This also means there's no additional configurations you can make. For example, you can't configure this switch to have different VLANs on different interfaces. Effectively, the entire switch is one big VLAN. This also means there's no way to configure this switch to communicate back to any of your management stations. So there's probably no SNMP or Simple Network Management Protocol functionality. There's no logs that's being stored on this switch. It is effectively an unmanaged switch. But one of the advantages of not having a lot of different configuration settings and options is that there's usually a lower price point. So if you're looking for a simple connectivity device that doesn't have a lot of configuration options, you probably want to use an unmanaged switch. On an enterprise network, however, you need a switch that you're able to manage remotely, configure with advanced settings, and if that's the case, then you need a managed switch. A managed switch is usually a larger device. This often has VLAN functionality, so you can configure different VLANs on different interfaces. It might have a way to prioritize different traffic patterns so that your web traffic might have a higher priority than your FTP traffic. These might also provide with redundancy support, so you can have multiple switches on your network at the same time and configure them in a way so that they are redundant to each other. If you lose one of the switches, you have a power failure, or the switch itself fails, you have another switch on the network that can take up the additional load. Many managed switches also allow you to perform port mirroring. That means you can plug in a protocol analysis tool or other security device to any of these interfaces and then redirect or mirror traffic from one interface to
So a
that
managed
other
switch has more
device.
management
So if you
configuration
are
and
in an
security
enterprise
controls. You
and
can do more
need
with it.
remote management functionality through
Yes, and
SNMP or a direct configuration
it
option,
can be
you
managed
might want to
externally.
use a
So you
managed
would use
switch.
that in an enterprise or corporate environment.
Comptia.com's intuitive work management platform, you have the power. Not IT, not admins. You're in charge. So you can tailor work exactly how you.
If you have devices that need to connect to the network over a wireless connection, then you need an access point. This is a bit different than the wireless router that you might have in a small office or home office configuration, because this is not a router. It simply switches between a wired network on one side and a wireless network on the other. We often refer to this as a bridged communication because there's no translation of IP addresses, there's no routing that's taking place. We are effectively switching between a wireless network and a wired network on the other side. Because of that, an access point is making its forwarding decision very similar to a switch because it's looking at the destination.
So it extends a
MAC
wired
address.
network
That
onto the
means
wireless.
the access point will evaluate a frame and determine if that frame needs to go out the wireless network or if it should be forwarded onto the wired network. If you were to look at a corporate network, you would see a lot of cubes and offices that are out on the floor of a building.
Interesting.
Each one of those desks is probably connected back to a central closet using an Ethernet cable. That cable is usually terminated inside of that closet onto a punch-down block. This allows you to run that cable between the desk and the closet and lock everything down onto that punch-down block. This greatly simplifies cable management because we know that cable between the desk and the closet is never going to move. But there may be times where a person in one desk may need to connect to a different switch or a different VLAN. For that reason, on the other side of the patch panel, we may have RJ45 connectors where we can move things around whenever we'd like. For example, we might plug into a particular switch using those RJ45 connectors on the patch panel. But if we ever need to change any of these connections, we leave the entire run between the desk and the patch panel in place, and we simply change where things are plugged in on the other side of the patch panel. If you need connectivity to a different switch or a different VLAN, you can do all of that from inside the closet without ever
That's interesting.
touching that extended connection.
That's how cable
between the
infrastructure
desk
would look
and
in
the
a
closet itself.
corporate remote or
Here's
corporate
one side of
environment.
the patch panel. You can see there are different connections coming from the desks, and they're numbered so that we know exactly what desk that cable is going to. That connection to the desk is probably punched down on the other side of this connector, and then there's the RJ45 connector. You can see there are inside the closet without ever touching that extended connection between the desk and the closet itself. Here's one side of a patch panel. You can see there are different connections coming from the desks, and they're numbered so that we know exactly what desk that cable is going to. That connection to the desk is probably punched down on the other side of this connector, And then there's the RJ45 connectors on our side that we would then use to connect to a switch interface. This is why we have permanent connections between the desk and the closet, so we know that that Ethernet connection
So those
is
are punch down
always going
blocks
to
and
be static
RJ45
and will be
connectors.
unlikely to have any type of wiring issue. And on the inside of our closet, we can change this configuration anytime we'd like with a relatively short cable that we could swap out if we ever run into a problem. This also allows us to extend the functionality inside of our closet to add or remove different switches, and then we simply connect through different interfaces using this side of the patch panel.
Duo redefines identity and access management with a security-first approach, making it the only.
Here's a very simplified view of this, where we have a patch panel at the top coming from desk 9, desk 10, desk 11, and you can see a very short cable is used to then connect those desks to the appropriate interface on the network switch. Another important device, especially for our security, is a firewall. A traditional firewall makes decisions about allowing or disallowing traffic based on the port number of traffic that's traversing the firewall. So a firewall will look at the TCP or UDP port number and then compare that to a set of access lists inside of the firewall that determine whether that traffic is allowed or disallowed. Our more modern firewalls are next generation firewalls, and they make these forwarding decisions based on the application.
Interesting.
So a firewall might allow web traffic to traverse the firewall, but block any type of remote access software. That decision is not being made based on the port number, but is instead looking at the application.
So you can look at
traffic
port
itself.
number and the
Many
application
firewalls
itself
can
that the
also
traffic
be
is coming
used
from.
as a VPN concentrator. So you can use this as a front end to have site-to-site VPNs, or have it as a centralized concentrator for remote access VPNs. Some firewalls might also act as a proxy, where they sit in the middle of a conversation, take a request from a client, pass that request on to the server, examine the response from the server, and only then provide that data back to the client. And in many organizations,
Proxy
these
is like a
firewalls are
middleman
installed as
in internet
routers.
terms,
So
I guess.
not only are they providing this security function, they're also routing between different IP subnets. And on larger firewalls, you might have many different interfaces where you can connect tens or even hundreds of networks to each other, all managed and controlled through the security built into this firewall. Our Ethernet networks used to pass only data through those wires, but these days we can include data and power over the same wire, all running over that Ethernet connection. We refer to this as Power over Ethernet, or PoE. We often use PoE to power our telephones on our desk, any type of access point that we would hang on the ceiling, or any other devices that connect to this network. This can certainly simplify the process of installing some of these components, especially when you have wireless access points that are in difficult places to get to in the ceiling. You would only need to run a single Ethernet connection that is providing both the data and the power for that access point. Many switches have Power over Ethernet built into the switch itself. But if your switch doesn't support any type of PoE, you can use an injector like the one you see here. You would disconnect your Ethernet cable, put the injector in the middle, and then plug the injector into a power source to provide PoE over that connection. When the PoE power is coming from the switch itself, we refer to that as an in-span, and if you're using an injector, it's referred to as a mid-span. If you're not sure if your switch supports PoE, it's usually marked on the switch itself. On this switch, you can see it does have a PoE, and it shows that all
Yeah, what with
to as a
built-in
mid-span.
power is an N-span.
If you're not sure if your switch supports PoE, it's
N-span,
usually
what
marked
looks
on the
over.
switch itself. On this switch, you can see it does
PoE,
have a
okay.
PoE,
Power
and
over
it shows
Ethernet.
that
Okay.
all of the interfaces that are marked in blue
Gucci.
can be used for Power over Ethernet. You might also look at your switch documentation to see what type of PoE is supported. The one that is simply PoE is the original PoE specification that provides 15.4 watts of DC power over a maximum current of 350 milliamps. That original specification was great for powering things like phones and other smaller devices, but we quickly found that we needed a bit more power for our remote devices. That's why we created PoE Plus. That's 25.5 watts of DC power with a maximum current of 600 milliamps. With PoE Plus, we can connect larger devices that require a bit more power, things like a pan, tilt, and zoom camera, for example. And these days, we can use PoE to even power our laptops with PoE++. That's 51 watts at 600 milliamps current, or 71.3 watts with 960 milliamps current, depending on the capabilities of your switch. PoE++ is the version that was introduced with 10 gig Ethernet running over copper cables. And although these PoE standards are downward compatible, they obviously are not upwards compatible. For example, if you have a device that needs a lot of power, for example, it needs a PoE++ type connection, you will not be able to power that device with PoE plus or lower.
Makes
This
sense.
allows you to power many different types
Makes a
of
lot of
devices on
sense.
your network without having to worry about wiring, where the power may be coming from, or changing anything with your Ethernet network. If your internet connection comes from a traditional cable television provider, then you're probably getting your data connection from a cable modem. This uses a broadband connection, usually provided over a coax link, and that is providing an Ethernet connection on the other side. So we're able to connect to the same network that sends our television signals, and also
By cable modem, is he talking about the cable itself, or is he talking about
on your network without
a
having
device
to
or
worry
part of
about
the device?
wiring, where the power may be coming from, or changing anything with your Ethernet network. If your internet connection comes from a traditional cable television provider, then you're probably getting your data connection from a cable modem. This uses a broadband connection, usually provided over a coax link, and that is providing an Ethernet connection on the other side. So we're able to connect to the same network that sends our television signals and also send our data across that same line. You'll sometimes see these cable modem devices referred to as a DOCSIS device. This is
DOCSIS.
referring to the standard used to transmit that signal across the cable network.
So many
This is
acronyms.
referring to
Oh my
data
god.
over cable service interface
So many
specification.
acronyms.
We commonly
I
see
wonder if
1
they
gig
come up on the
communication
exam.
and higher on these cable modem connections, and this is something that is a common connection for
Gigabit.
people that already have cable television in their home. And since
So if you have
are getting
cable
such
TV, you
high
probably have that.
throughputs over these connections, it's also
Yeah,
very
service
common to
provider,
see
ISPs
this in
normally
corporate
ask you that.
environment as well.
It's the autumn summer sale. Pick up the Samsung Galaxy S25 Ultra and save up to 5.
Although you may not even be using the television or the voice communication, having that high-speed data on a cable modem can be very valuable in almost any data center. Not everyone has the connectivity of a cable network, so instead you may be using a traditional telephone network, and you can run a digital internet connection over that using DSL or digital subscriber line. This uses the same wires that you use for your analog telephone, but also sends digital signals across it at the same time. DSL can give you reasonably good throughput as well. It's not uncommon to see 200 megabits downstream and 20 megabits upstream on many DSL networks. That throughput is affected by your distance from the central office, and there is a limitation of approximately 10,000 feet. You have to be sure that central office is at least somewhat close to where you will be connecting to the
10,000
network.
feet.
Because of
What's
that,
that in
you'll find
miles?
the closer you get to the central office, the faster the download and upload speeds will be on this DSL network. You might be lucky enough to have fiber that's in the ground outside of your home or
Fiber!
office, and in that case, you may connect to that network using an ONT. That's an optical network terminal that converts the fiber coming into your home or business into
That's
copper
how
connections
fiber
that you
optic
can
works.
use on a traditional network. This ONT device is usually in a central place or a demarcation point or DMARC. This may be in the data center itself, or it may be in a box that's on the outside or just inside of your building. We refer to this as the demarcation point because this is where we determine what part of the network is the responsibility of the user and what part of the network is the responsibility of the service provider. This ONT effectively creates that demarcation point so that any of the wiring on the inside of your building is your responsibility, but any problems with the network outside of your building are the responsibility of your internet service provider. Here's a better view of this ONT. There's a fiber connection coming into this link that's on the ONT. Then you can see there's not only RJ11 connections that would be used for voice communication. This is probably a voice over IP that has phone numbers associated with it. And there's also a data connection that has an RJ45 connector, and that's probably outputting an Ethernet link that you could then plug into a router. This ONT can also be used for video, so you'll notice there's an F connector on this as well that you can plug in a coax connector that would then go to a cable box or directly to a television. And of course, we'll eventually need to connect devices and servers directly to the Ethernet network, and we do that by using a network interface card, or a NIC. This is what we have built into system boards that are in our laptops and desktop systems, or we might have a separate interface card like the one you see here that can provide multiple Ethernet connections on a single card. There are many different types of network interface cards. You could get one for a 100 megabit Ethernet.
Every device has a
gig
network
Ethernet
interface
over
card.
copper. Maybe this network interface card has fiber connectors on the back of it, so you'll need to make sure you're using the right kind of network interface card for the network that you're connecting to. These separate expansion cards allow you to extend the functionality of your existing device. If there's no Ethernet connection on your motherboard, you can add Ethernet connections that way. Even
This
if
allows
there
you to
is
add
an
Ethernet
connection
connections.
built into the motherboard, you can add additional Ethernet interfaces by simply adding one of these expansion cards. And since this is an Ethernet device, each one of these interfaces has its own media access control address, or MAC
address for each
so that
one.
we can individually reference each of these interfaces across the network.
Next video.
What if you could do all your SEO in one tab? Meet SEMrush, a tool to find winning keywords, create top-ranking content, track your competitors, build backlinks, and fix technical issues. All in one platform. And it's free for 7 days.
If you've ever communicated across the network, then you've probably used IP version 4. IPv4 is one of the most popular protocols in the world, and you need to know how to configure a system with IPv4 configuration parameters as part of the A+ exam objectives. Not only do we need to understand IP version 4, we need to understand the most recent version of IP, which is IP version 6. There are some similarities in operation between
I'm
these
live
two
on
different
video,
IP
but there
versions,
was what's up?
but there are significant differences on how they look and how you configure them on a system.
Huh?
IP version 4
If
is
mommy
a
says it's okay, you
32-bit
can.
address.
Don't come
There
here,
are
it's cameras
32
on.
ones and zeros that work together to create that IP version 4 address. An operation between these two different IP versions, but there are significant differences on how they look and how the most recent version of IP, which is IP version 6. There are some similarities in operation between these two different IP versions, but there are significant differences on how they look and how you configure them on a system. IP version 4 is a 32-bit address. There are 32 ones and zeros that work together to create that IP version 4 address. From a human perspective, it's easier to represent this in a decimal form, and we represent it as 4 separate decimal numbers. For example, on this address, we have 192.168.1.131 numbers. For you to represent this in zeros, you configure them on a system.
Getting juicy.
IP version 4 is a 32-bit address.
Yeah.
There are 32 ones and zeros that work together to create that IP version
It's
4
called for
address.
the table.
From a human perspective, it's easier to represent this in a decimal form, and we represent it as 4 separate decimal numbers. For example, on this address, we have 192.168.1.131, and all of those together make up the IPv4 address. If you wanted to represent this in binary, you could write out all the ones and zeros associated with each of those numbers. Each of those 4 numbers is referred to as
Bruh,
one
I'm
dot
getting
to
lost here.
represent
Okay.
the IP version. IP version 4 is a 32-bit address. There are 32 ones and zeros that work together to create that IP version 4 address. From a human perspective, it's easier to represent this in a decimal form, and we represent it as 4 separate decimal numbers. For example, on this address, we have 192.168.1.131, and all of those together make up the IPv4 address. If you wanted to represent this in binary, you could write out all the ones and zeros associated with each of those numbers. Each of those 4 numbers is referred to as an octet because it is made up of 8 different ones or zeros. Sometimes we'll refer to this as a byte. Zeros associated with each. We have 192.168.1.131, and all of those together make up the IPv4 address. If you wanted to represent this in binary, you could write out all the ones and zeros associated with each of those numbers. Each of those 32-bit address. There are 32 ones and zeros that work together to create look and how you configure them on a system. IP version 4 is a 32-bit address. There are 32 ones and zeros that work together to create that IP version 4 address. From a human perspective, it's easier to represent this in a decimal form, and we represent it as 4 separate decimal numbers. For example, on this address we have 192.168.1.131, and all of those together make up the IPv4 address. If you wanted to represent this in binary, you could write out all the ones and zeros associated with each of those numbers. Each of those 4 numbers is referred to as an octet because it is made up of 8 different ones or zeros. Sometimes we refer to this as a byte or 8 individual bits. When you combine all of them together, you have 32 bits, which is also equal to 4 total bytes. Another interesting thing to keep
I definitely need to screenshot this and come back.
in mind is that these 8 bits together can consist of a number between 0 and 255. So none of these octets will ever exceed the value of 255. For us to communicate across the public internet, every device needs to
8
have
bits
a
is 1
unique
byte,
IP address.
and 1 byte is 1
For
octet.
example, one device could have an IP address of 1.1.1.1, and that device can communicate to a device that has an IP address of 1.1. This needs to have ever exceed the value of 255. For us to communicate across the public internet, every device needs to have a unique IP address. For example, one device could have an IP address of 1.1.1.1, and that device can communicate to a device that has an IP address of 2.2.2.2. As you can probably tell, there's a finite number of IPv4 addresses that you can create based on the combinations of numbers that might be available. And if you do the math, there are about 4.29 billion combinations of IPv4 addresses that you could create. However, there are over 20 billion different devices connected to the internet, and that number is rapidly growing. So how do we connect and communicate between all of these different 20 billion devices if there's only 4.29 billion addresses to go around? One of the ways we're able to do that is by taking some of those addresses and changing them into a private address using a technology known as Network Address Translation, or NAT. On the internet, public addresses can talk to public addresses. But on a company's network, there may be a single link out to the internet where there might be a single public IP address, but inside of their private network may be hundreds or even thousands of other devices that we can assign a private address. Private addresses allow us to communicate with each other inside of our private network, and using network address translation, we can communicate outside of our network. The benefit, though, is that none of those private addresses go towards that entire pool of IP version 4. This means that we could have hundreds or even thousands of those devices internally, and then when we need to communicate out to the internet, we can do that over a single IP version 4 address. This range of private addresses that you might configure on your local network is defined in an RFC numbered 1918. RFC stands for Request for Comment, and in this particular form, this means it's a standard that we use across the world for IPv4 addressing. If we were to look at RFC 1918, you would see 3 separate ranges that you could use as private addresses on the inside of your network. And some of these addresses you've probably seen before. For example, you can use the range 10.0.0.0 through 10.255.255.255. This allows us a combination of over 16 million different addresses that we could have inside of our network, which is probably why this is one of the most popular address ranges used inside of a large corporate network.
What if you can create your own website by saying, this is what I want? With Wix, you can.
On a smaller network, you might use the range 172.16.0.0 through 172.31.255.255. This combination gives us just over 1 million addresses that we could use to define private devices on our internal network. And if you use a network at home, then your local device probably assigns IP addresses using the last private range, 192.168.0.0 through 192.168.255.255. This provides a total number of just over 65,000 addresses, but for a network at home, that is plenty of IP addresses to use to be able to have a private network internally that you could then
Barely
network address
grasping this
translate
part.
into a
I
single
guess he's
address
just
on the
talking
outside
about
of
the
your
range of
network.
private IP addresses you can get.
When we started
Don't know when I'd
designing
need to know that
IPv6,
for
being able
the
to get
upcoming
around
exam.
this problem with a limited number of IP addresses was one of the major architectural concerns. For that reason, IPv6 addresses are much larger than IPv4. IP version 4 addresses are 32 bits in length. An IPv6 address is 128 bits in length. This greatly expands the size of available addresses to 340 undecillion addresses. This means if there's about
Undecillion,
6.8
how much is
billion
that?
people, each one of those folks can have a very large number of addresses for each individual user. This greatly expands the number of addresses available across the world and removes any limitations that we previously had with IP version 4. The structure of IPv6 is also very different. You'll see IPv6 addresses written in hexadecimal format rather than decimal so that we can fit a lot more of this address into a smaller place. For example, this is an IPv6 address written out with the hexadecimal ranges and double colons and colons to separate the different areas of the network. If we were to write this out in its full and complete form, it would be the one that is on the screen in the middle here of FE80 colon 0000 colon 0000 colon 0000 colon 5 Delta 18 colon 0652 colon Charlie Fox Fox Delta colon.
I don't know how he
8
doesn't
Fox
stutter,
52.
Professor
That
Messer.
is a very large
Hats
address
off.
to be able to write out.
I don't know
but
how
it
you
gives us
speak for
enough
so long without
addresses that we
stuttering
could
at
use
all.
this
Probably have a
across
good
the
editor,
world
but
for the global internet and connect
Crazy.
everyone who needs that connectivity. Just like IP
so
version 4,
IPv6
we can
expands
show
the
IP
total
version
pool of
6
addresses available,
in binary, and in this particular case, instead
and
of
it
having
has
an
128
octet
bytes.
to be a single
So
group,
it's not an
in this
octet.
case,
This
it's
is like
double that
2
size
octets.
at 16 bits, or 2 octets
Yeah.
for each one of these groups. That's another reason that we display this in hexadecimal form rather than having very large numbers with periods in between. Instead, we can use hexadecimal to make this much smaller and use colons to separate each of these individual blocks within an IPv6 address. And if you count up the IPv6 address in total, it's 128 bits in length, or a total of 16 bytes. Because the IPv6 address is much larger and much more difficult to memorize than IP version 4, DNS now becomes very important. Instead of having to memorize an IP version 6 address, we'll rely on DNS to be able to reference these addresses by their fully qualified domain name. We also don't do a lot of subnetting with IP version 6 because, quite frankly, we don't need to. We have an enormous number of networks and an enormous number of devices that we could put on each of those networks. Usually the first half of the
I missed
DNS
it.
now becomes very important. Instead of having to memorize an IP version 6 address, we'll rely on DNS to be able to reference these addresses by their fully qualified domain name. We also don't do a lot of subnetting with IP version 6 because, quite frankly, we don't need to. We have an enormous number of networks and an enormous number of devices that we could put on each of those networks.
So no
Usually the
subnetting.
first half of the IPv6 address, or the first 64 bits, are considered to be the network prefix, which means the default subnet mask for any IPv6 address.
So
Half of the IPv6 address, or the first 64 bits, are considered to be the network prefix, which means the default subnet mask for any IPv6 address is usually a /64. That means the last 64 bits of the IPv6 address are used as the host address. So our network is the first half, and the hosts are the second half.
network
So
first,
if you're
host
designing
second.
and implementing an IPv6 network, you're probably using the first half of that IPv6 address as the network prefix, and the second half of the IPv6 address as the specific host ID.
Interesting, very dense, a lot to take on. Okay, fun though.
Trust is over. Traditional identity and access management, or IAM, no longer keeps us safe.
We are on assigning IP addresses. Yes.
If you're responsible for configuring IP addresses on a device, you know there are a number of important parameters that you'll need to add. One of these, of course, is the IP address itself. Every device needs a different IP address, and you may need to assign these manually or configure this IP address into the configuration of the service. So you may add, for example, 192.168.1.165, and now you've configured the IP address. But of course, you don't have an IP address unless you also have a subnet mask.
Why
The
though?
subnet mask is used by that local device to determine which subnet it actually sits on. When we refer to an IP subnet, we're
It's like a
referring to the
postcode, right?
combination
Or
of
city.
an IP address and a subnet mask. A typical subnet mask might be 255.255.255.0. And since the subnet mask is not something that's commonly sent across the network, we'll need to get with the network administrator for that IP subnet to confirm that we have the correct subnet mask. And if this device needs to communicate outside of this local subnet, they'll need the IP address of the local router. This is often referred to as a default gateway.
That's
For
why it's
example,
called
the
default gateway.
on this network might be
That makes
192.168.
sense. I never
For
understood
example,
that.
the default gateway on this network might be
If you ever had that error message.
192.168.1.1. You'll commonly be provided with all three of these by the network administrator, and this is what will give you the basic connectivity to communicate on your local subnet and outside of this local subnet. There may be other parameters that you need to manually configure, such as DNS server configurations, NTP servers, voice over IP servers, and other important IP configuration parameters. In an earlier video, we talked about DHCP, or the Dynamic Host Configuration Protocol, and how
Yeah, that one's worth screenshotting, even though for some reason, ended up typing what it says. I feel like it sticks in their brain a bit better like that. The default gateway must be an IP address and also that. On the local subnet.
servers and other important IP configuration parameters. In an earlier video, we talked about DHCP, or the Dynamic Host Configuration Protocol, and how it's used to automatically assign IP addresses on your devices. But there may be times when we don't want to have our IP address pulled randomly from a DHCP pool. Instead, we would like the IP address for a device to always be that. In an earlier video, we talked about DHCP, or the Dynamic Host Configuration Protocol, and how it's used to automatically assign IP addresses on your devices. But there may be times when we don't want to have our IP address pulled randomly from a DHCP pool. Instead, we would like the IP address for a device to always be that IP address. We refer to this IP address that doesn't change as a static IP address. One common way to assign a static IP address is to type it in manually on that device. You can usually find this in the configuration settings of this device, where you can input the IP address, the subnet mask, the gateway, a preferred DNS, and other important IP address configuration options. This is one where we have to make sure that what we're typing in is exactly correct, because this is not something that's provided automatically. If we make a mistake typing this in, then this device won't be able to communicate properly on the network.
Okay.
But manually configuring IP addresses on all of your network devices can be time-consuming and difficult to manage. What if you'd like to change the IP address of your default gateway? Or what if the IP addresses of your DNS servers happens to change? You would have to manually go back to all of those devices and type in the new parameters. That process may be something easy to manage if you have a handful of devices at home. But in a company where you have hundreds or even thousands of devices, manually configuring static IP addresses is not very scalable. Generally speaking, manually configuring IP addresses is not the best practice. But there are ways to manually set static IP addresses on a device on the DHCP server itself. That's a central point where you can manage all of these IP addresses.
My laptop might die
And
at
it's a
some point.
configuration
It seems
setting
like it's
inside
still
the
charging.
DHCP server called a
The stream's still
DHCP
okay. I don't know.
reservation. This is a process that links the MAC address of this device to a specific IP address. So instead of configuring these manually, you would change that configuration setting to DHCP. This device will then access the DHCP server, find that there is a DHCP reservation, and always use the same static address because it has been administratively assigned on the DHCP. Access the DHCP server, find that there is a DHCP reservation, and always use the same static address because it has been administratively assigned on the DHCP server itself. Now, if you change the IP address of your default gateway or the IP addresses of your DNS servers change, you configure that on your DHCP server, and the next time the system starts up, it will receive
Okay, so
a set
manually
of IP
inputting
parameters
static
without
IP
you having
addresses
to
doesn't make
even
sense
visit
for the
that
most part or
device.
in most use cases.
Most of
And
us
you want to
rely
use a
on
DHCP
DHCP
protocol or
provide
server
that
to
automatic
automatically
IP
configure them.
addressing mechanism.
Understood.
If you're working on a
A
computer
pipa.
at home, at work, at a hotel, or a coffee shop, you've probably been assigned an IP address automatically using their local DHCP server. But what if you're on a network that doesn't have a DHCP server and your system is configured to look for that DHCP configuration? In those situations, your device is not going to receive a DHCP address, and so it's up to the device to determine what to do next.
Okay, let's go back.
Doesn't have their
I was waffling and missed that. Let's go.
Most of us rely on DHCP to provide that automatic IP addressing mechanism. If you're working on a computer at home, at work, at a hotel, or a coffee shop, you've probably been assigned an IP address automatically using their local DHCP server. But what if you're on a network that doesn't have a DHCP server and your system is configured to look for that DHCP configuration? In those situations, your device is not going to receive a DHCP address, and so it's up to the device to determine what to do next. In most cases, the operating system is going to assign an APIPA address. This stands for an Automatic Private IP Addressing Scheme. We also refer to this as an IP version 4 link local address. This is an IP address that allows you to communicate with other devices on your local IP address subnet, but it's not able to route outside of your local subnet. This means you might not have internet connectivity because you're not able to route outside of your local subnet with an API-PA address.
So it puts you in
But
jail.
you are able to communicate with
Puts
other
your device in
devices
jail,
on
let's
your
say.
local subnet so that you can do some basic network troubleshooting and determine why you're not able to communicate with the DHCP server. The API-PA standard sets a block of addresses that could possibly be used for this linked local address. This is a very large range. It ranges between 169.254.0.0 through 169.254.255.255. This standard also reserves the first 256 addresses and the last 256 addresses, which means the IP address that you'll receive on your device via API-PA will be 169.254.1.0 through 169.254.254.255. If you look at the IP address on your device and you notice that it's in this range, then you know your device has assigned itself an API-PA address. This also means that your DHCP server is probably not communicating, and you'll need to troubleshoot that before you're able to receive DHCP assigned addresses again. When your computer realizes that DHCP servers are not responding and it automatically assigns itself an API-PA address, it has to make sure that nobody else is using the random IP address that it chose in that very large block. To be able to make this determination, your device sends an ARP request out to the network asking if any other device is currently using the IP address that it would like to use. For example, your device could randomly choose 169.254.77.77. So it will send an ARP request to your local subnet with a broadcast that says, does anybody else out there have 169.254.77.77? And if it does not receive a response, it assumes that that address is available to use, and it will automatically assign that IP address to your local machine. So if you're currently using DHCP and you notice that occasionally the IP address of your device will change to a different IP, then you may want to set something that is more static. If you're on a corporate network, then you're probably using some type of static IP addressing already. Your switches, your firewalls, your routers, and your printers are probably configured with a static IP address.
Take a break after this video. Probably call it
So
a
if
night
you're
on this
currently
and then do
using
some revision
DHCP
offline.
and you notice that occasionally the IP address of your device will change to a different IP, then you may want to set something that is more static. If you're on a corporate network, then you're probably using some type of static IP addressing already. Your switches, your firewalls, your routers, and your printers are probably configured with a static IP address. You could, of course, disable DHCP on those devices and manually type in all of your IP address configuration settings, but more commonly we'll use an IP reservation on the DHCP server so that every time you start your router, your switch, your printer, or any of these other devices, they will automatically receive the same IP address from the DHCP server because you've configured your devices.
So if you did want a static IP address, you want to create a DHCP reservation and you associate a MAC address with an IP address.
Automatically receive this so that every time all of your IP address configuration settings, but more commonly we'll use an IP reservation on the DHCP server so that every time you start your router, your switch, your printer, or any of these other devices, they will automatically receive the same IP address from the DHCP server because you've configured an IP reservation.
Architecture and interior design? Find a 3D designer today. Private. Start now.
These days you can be almost anywhere on Earth and have access to the internet. We're able to get that access thanks to satellite networking.
Right, I'm gonna take a break here, people. Or should I say nobody just yet. Ghosts and all. See you later. I may or may not come back online later, I'll see.